Okay, now let's take a look at adding polynomials together. So with addition, just like with subtraction, there is a 1 here, but when I multiply a positive 1 times the values behind it, that does not change my problem. If I take 1 times 2, that does not change it. So really, in reality, all we need to do is rewrite our problem without the parentheses. And I have a plus 2x to the second plus an x to the third minus 1. And then we want to combine like terms. So again, I just always start in the left side. So I have an x to the third, and then I scan it. Whoops, I forgot my plus sign here. X to the third, and here's another x to the third. That's a 1 right there. So if I have 2 here and 1 there, that means I have 3x to the third. Notice that doesn't become an x to the sixth. Think about apples. If you have 2 and I give you 1 more, you have 3 apples. The apples don't just automatically become oranges because I've combined them. So that x to the third does not change. So that takes care of that one. And then the next thing I have is a negative 5x to the second. And then I have a positive 2x to the second. So negative 5 and 2 give me a negative 3x to the second. So that takes care of that one. And then I have an x here. And I don't have anything else that has an x. So then I just write that. I just bring it down. And then the only other thing I have left is a minus 1. So then I look at that and I see I go from high to low. My power is 3 to 2 to 1 to nothing, which means that's written in standard form. So that is my answer. And this would be classified as a polynomial because there are 4 terms. Just for practice, our degree, if you look, our highest exponent is 3. So that's our degree. And then my leading coefficient is going to be 3 because that's the first number in the answer. Let's take a look at example B. Again, there's a plus sign. So when I distribute that plus, that's just a positive 1 right there. Not going to change it. So we have 3x to the second plus x minus 6 plus x squared plus 4x plus 10. And then we just start. Here's an x to the second power. And here's an x to the second power. That x has a 1 with it. So if I have 3 and 1, I have 4x to the second. So that takes care of those. And then I have an x here. So there's a 1 and a 4x. So that gives me plus 5x. Takes care of those. And then I have a minus 6. It does not have a variable, but neither does this 10. So negative 6 and 10 give me 4. And then that takes care of everything. So that is, everything is combined. So then I look, are my exponents going from high to low? Yes, they are. 2, 1, and none. And so then this is my answer. And then again, let's just name it. This would be a trinomial because there are 3 terms. There's one right here, and one right here. My degree would be a degree of 2 because that is my highest exponent. And then my leading coefficient is 4 because that's the very beginning of my problem. That is the leading number. And that is how you add polynomials.